Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 11.1, Problem 10. This is Section 11.1, Problem number 10. It says, use the chart provided to compute the limit as x approaches 4 of x to the third power minus 64 over x minus 4. And again, ordinarily with taking a limit, the first thing I would like to do is put in the value that they want to approach for an input value for x or whatever the variable is and see what happens. And we can see that we're zeroing out the denominator. So it'd be actually very easy to take the limit of this function as it approached negative 4 would be okay, or 5, or anything else that didn't zero the denominator out. But because it's a 4, and putting in a 4 for x will zero the denominator, I have to find a different approach. My next thought would be factor it somehow and cancel the denominator out. That can be done, but not in a way that most people recognize easily. So we resort to filling in a chart and actually brute force method kind of plugging in things that are super close to 4. So as we fill in this chart, the top row is telling us to use as an input value 3.9, that's close to 4. Then use it as an input 3.99, that's even closer to 4. And then 3.999, that's even closer to 4. So as our inputs get closer and closer to 4, see what the function would be doing. So let's give that a try. We're going to put in 3.9 first as our input value or x value into the function that's given. So the x cubed becomes 3.9 cubed, or third power. We're going to subtract 64. And then the denominator, x minus 4, becomes 3.9 minus 4. And we'll just do that math again because of the third power and the decimals involved. You're going to want to do it on a calculator, which will go reasonably quick. So 3.9 third power, 3.9 times 3.9 times 3.9. I get an answer of 59.319. I'm going to subtract 64 from that answer. So in the numerator, I have negative 4.681. And I'm going to divide that by the denominator, which I can see is negative 0.1 actually. The negatives will cancel. And the answer comes out to 46.81. So if I put in a 3.9 for x, the y comes out to 46.81, a positive 46.81. So next, let's use an input value or x value that's even a little closer to 4, 3.99. So again, for this function, the top, the x cubed will be 3.99 cubed, or third power if you like, minus 64. And then the denominator, x minus 4, becomes 3.99 minus 4. And now again, we'll do the math. I'll do it out on the calculator and see what I get as an answer. Start with 3.99 to the third power. And the calculator tells me that's 63.521199. I'm going to subtract 64 from that result. Now the numerator is negative 0.478801. I'm going to divide that result I got from the numerator by, I can see the denominator will be negative 0.01. So let me just divide that. And I get positive 47.8801. So if I put in 3.99 for x, the y value comes out to 47.8801. So next, let's try an input value even a little closer to 4. I'm going to put in 3.999 as an input. That's very close to 4. So in the numerator of my function, x cubed will be 3.999 cubed, or third power is a different way of saying cubed. Now for this function, I want to subtract 64. Again, just because I'm working with the function that's given to me. And in the denominator, x minus 4 will be 3.999 minus 4. And the calculator will compute that fairly quickly for me. So 3.999 raised to the third power gives me a very big long decimal, 63.952012. I'm going to subtract 64 from the result I got. And again, the calculator tells me in the numerator of this problem, I'm getting negative 0.047988001. I'm going to divide that by, I can see the denominator will be negative 0.001. I can do that subtraction in my head. And the result comes out to positive 47.988001. So if I put in a 3.999 for x, I get a 47.988001 out for y. So it seems that my outputs are getting closer to a value of 48. But you have to make sure that you're getting closer and closer to the same value as you try input values slightly less than what you're approaching and slightly more than what you're approaching. Occasionally they'll go to two different outputs and then the limit does not exist. So let's fill in the bottom. Next I'm going to try an input of 4.1 for x. That's fairly close to an input of 4 and see what I get for an output. Again, in the numerator, x to the third will become 4.1 to the third power minus 64 divided by x minus 4 becomes 4.1 minus 4. So I put in a 4.1 for x. I'll do the math with my calculator, of course. 4.1 third power equals, I get 68.921. I'm going to subtract 64 from that. I get 4.921. I'm going to divide on the bottom by 0.1. And when I do the math, the result comes out to 49.21. In the next box, I will use an input of 4.01. That's getting a little closer to an input of 4. So when I do, x to the third will be 4.01 to the third minus 64 over x minus 4 now will be 4.01 minus 4. And I'll do the math for that. 4.01 third power gives me 64.481201. I'm going to subtract 64 from that. So minus 64 equals. The numerator, I get 0.481201. I'm going to divide that result from the numerator by 0.01. I can see that's what it's going to be. And the overall final answer I get is 48.1201. So my output does look like it's getting close to 48. We'll do the next box just to make sure. Again, as I put in an input value or x value of 4.01, the output or y value I got was 48.1201. So one more value that's really close to 4, put in an input of 4.001. That's really, really close to 4. So the x cubed in the beginning will be 4.001 cubed, or again, in other words, you could say third power. Whatever I get as a result for that, I'm going to subtract 64. It has a denominator, x minus 4, which will become 4.001 minus 4. And again, I'll do the math. 4.001 third power is 64.048012. I'm going to subtract 64 from that result. And I get 0.0480120001. I'm going to divide that numerator by 0.001 basically after I do the subtraction. And the answer comes out to 48.012001. So now that the chart's filled out, it seems that the value of the limit is 48. As I put in input values that are getting closer and closer and closer to 4, the output is getting closer and closer and closer to a height of 48. So again, because I can never actually put in the 4, because it was 0 the denominator. I never really actually hit a height of 48 on the graph. I can come very close to that height of 48, really, really close, but I never get exactly a height of 48. So if you saw the graph, there'd be a little open circle at that over 4 up 48. So you can get as close as you want, but you never actually hit that height of 48.